So when 3 p orbitals and 1 s orbital, when it is combined to form a Sp3 hybrid orbitals. Equatorial hybrids are consists of 3 hybrids which are equivalent and they are directed towards the corners of the equatorial triangle, and the angles will be around 120. In case of PCl5, which undergo the involvement of the d orbital, hence it is known as Sp3d hybridization. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Chemical Bondings and Molecular Structure. Under that, we have deeply discussed with hybridization, and we are also discussing about the types of hybridization. Under that, we have discussed about the Sp hybridization and Sp2 hybridization. Today, we will continue with the other types of hybridization. So, I will go with the Sp3 hybridization today, and we are going to discuss about Sp3d hybridization, and lastly, we are going to discuss about Sp3d2 hybridization. Okay. So, first I will go with the Sp3 hybridization. So, here the Sp3 hybridization, the name itself shows that there are 3 p orbitals and there are only s orbital. When s orbitals and 3 p orbitals, when it is combined, then we can say such hybrid orbitals as Sp3 hybrid orbitals. And remember, in case of this Sp3 hybrid orbitals, the 4 Sp3 hybrid orbitals are oriented in tetrahedral geometry with a bond angle of around what? 109.5 degree, and with the angle between any two atoms. And it exhibits that 55% of S characters and remaining, the 75% will be there for the p orbital because it is Sp3. 25% of S character will be seen and 75% of P characters will be observed in Sp3 hybridization. And the example for this is, you can see that here we have S orbital which is in a spherical shape, and you can see that this is a p orbitals which are in the dumbbell shape. So when they overlap, which results in a formation of Sp3. Remember, I have written 3 different orientations for the p orbital. That is, here it is present in axially. These are the lateral and the sideways. Okay. So when 3 p orbitals and 1 s orbital, when it is combined to form a Sp3 hybrid orbitals. Okay. And it will be having which geometry? It will be having what? Tetrahedral geometry. You can see that it has tetrahedral structure with a bond angle of 109.5 degree. Okay. Now let us see which all the example will be studied under Sp3 hybridization. If I talk about Sp3 hybridization, we have an example of methane molecule. Is it right? Yes. So in the methane molecule, the carbon atom which is undergo what? Sp3 hybridization, and in excited state, it consists of 4 unpaired electrons, and these 4 unpaired electrons are get paired up with the 4 different hydrogen atom and results in a formation of tetrahedral geometry. Now let us see the ground state electronic configuration of the carbon and excited state electronic configuration of the carbon. You can see that in the ground state it has how many electrons? It has 6 electrons, especially in the p orbital which consists of 2 electrons. When it is get excited, one of the electrons from the s orbital will be moved towards the p orbital and become 4 unpaired electron, and becomes how many electron unpaired? 4 electron. And all these 4 unpaired electron, when it is reacting with 4 different hydrogen atoms which are donating 1 electron and results in a formation of tetrahedral geometry. You can see that these are the carbon atom which are having 1 electron which has been shared with the hydrogen atom and forming methane molecule. Hence this hybridization which is known as Sp3 hybridization. Why it is known as Sp3? Because in the S orbital we have only 1. Similarly in the P orbital we have how many electrons? 3 unpaired electrons. So together it is known as what? Sp3 hybridization. Next is Sp3 hybridization in C2H6 molecule, that is in ethane molecule. Okay. So in ethane molecule, both the carbon atom is undergo Sp3 hybridization state and one of the 4 Sp3 hybridization orbitals of the carbon will overlap with the similar orbitals of other atoms to form sp3 sigma bond, while other 3 hybrid orbitals of each carbon atom used for forming sp3 sigma bond with hydrogen atom. Here you can see that we know that carbon is having how many electron? 6 electron. Is it right? Each carbon is having 6 electron and we write the electronic configuration as 1s2, 2s2 and 2p2. So there are 6 electrons will be there. We know that if you write it in the form of shape, okay. So this is 1s square, this is 2s square and this is 2p. So 1, 2 and there are 2 electron will be there. Is it right? When it is in excited state, what will happen? So the electron which is present in s orbital, is it right? The electron which is present in s orbital will be get shifted to the p orbitals and forming how many electrons unpaired? 4 electrons are unpaired. So among them, between 2 carbon atom, when they overlap, it forms sigma sp3 hybridization. Similarly, each carbon atom which donates 1 electron with the hydrogen atom and forming 3 sigma bond with hydrogen atom. You can see that this is the first carbon atom and this is the second carbon atom. It will share its valency or it will share its 1 electron with hydrogen atom and forming the ethane molecule. And the structure will be like this. Between the 2 carbon atom, you can see that the bond angle is around 109.28 degrees and between the 2 hydrogen atom also it is 109.28 degrees. And you can see that these 2 carbon atom which is undergo what? Sigma sp3 hybridization, and you can see that each carbon atom it is sharing 1 electron with another 3 sets of hydrogen atom and forming ethane molecule. So hope you understood with this sp3 hybridization. Always remember, if I say it is sp3 hybridization, so what will happen? There is a 1 s orbitals and 3 p orbitals. They undergo hybridization and forming a hybrid orbital. Okay. Next, let us see sp3d hybridization. This kind of hybridizations which always involves the d orbital. Hence, we can name that the hybridization involving an element which consists of d orbital. Okay. Now, let us see what is sp3d hybridization. Okay. In sp3d hybridization, we have 1 s orbital and we have 3 p orbitals and also we have how many d orbitals? Only 1. Hence, it is named as sp3d. Okay, it is named as what? sp3d. You can see that there is an involvement of d orbitals which has been there in sp3d hybridization. And equal energies are there intermixed to give 5 identical and degenerative sp3 hybrid orbitals. They are arranged in trigonal pyramidal geometry. You can see that this is a trigonal pyramidal shape of general structure of sp3d hybridized orbital. Okay. And next, among them, they are arranged in trigonal plane and remaining two orbitals are present just above and just below in the trigonal plane in the right angle. You can see that these three orbitals, they are present in trigonal planar structure. Is it right? And just above this and below this, you can see that one of the atomic orbitals will be there, and we say that it is the equatorial orbitals as well as the axial hybrids. Okay, equatorial hybrids are consists of three hybrids which are equivalent and they are directed towards the corners of the equatorial triangle, and the angles will be around 120. Similarly, we can define the axial hybrids also, that consists of three hybrid orbitals which are equivalent and they are oriented perpendicular to the plane and containing equatorial hybrids. Hence, they are known as axial or polar hybrids. And finally, we can say that Sp3d hybrid orbitals have 20% of S characters, 60% of P characters and 20% of D characters. We can understand this general concepts of Sp3d hybridization by taking some of the example. I'll go with the PCl5 now. Okay, so PCl5 is the best example for Sp3d hybridization and it is known as Phosphorus Penta Chloride. Okay, so first I'll go with the writing the general electronic configuration of the phosphorus. So in the phosphorus, we know that there are 15 electrons will be there and the electronic configurations will be goes like this: 1s2, 2s2, 2p6 and 3s2, 3p3. Is it right? I have considered only the last part, that is the 5 unpaired electron which is there in its outermost shell. Okay, when we have written the ground state electronic configuration of the phosphorus, we know that in the 3s orbitals we have 1 pairs of electron. Similarly, in 3p we have 3 electron. This is in a ground state. During the excited state, what will happen? One of the electron from the 3s has been shifted to the d orbitals and makes the 5 unpaired electrons in the phosphorus. When it is reacting with the chlorine, all the 5 unpaired electrons will easily get attracted towards the chlorine and chlorine itself donates 1 electron and results in a formation of PCl5. Okay, so phosphorus has got how many unpaired electron? 5 unpaired electron. Each 5 unpaired electron has bonded with each single chlorine atom and results in a formation of PCl5. And you can see that during this process there is a 1 s orbital, 1 3p orbital, and you can see that 1 d orbitals will be involved. Hence, this hybridization will be named as Sp3d hybridization. So, hope you all understood with the PCl5. Now, let us see the structures for this. You can see here, this is the structure of the PCl5, where you can see that the phosphorus which are having 1 unpaired electron which has been shared by the chlorine atom and forms what? PCl5. So, each chlorine atom will donate 1 electron so that it will form what? PCl5, and you can see that this is a trigonal structure and just above and just below the plane you can see that there is a 1 more orbital will be there. Hence, this structure which is known as trigonal bipyramidal shape, or you can write the structure like this also for the PCl5. Okay, so now let us see how many sigma bond will be formed here. Now, the 5 orbitals are available for hybridization to yield the 5 Sp3 hybrid orbitals which are directed towards the 5 corners of trigonal bipyramidal depleted in a figure. In PCl5, the 5 Sp3d hybrid orbitals of the phosphorus overlap with the singly occupied p orbitals of the chlorine atom to form PCl sigma bond, and 3 PCl sigma bonds are lying in a one plane, one with the bond angle of 120 degree and with each other, and each bonds are termed as equatorial bonds, and remaining PCl bonds are lying just above and just below the plane. Hence, it is also known as equatorial bonds with a bond angle of 90 degree. You can see that there are 5 unpaired electrons will be there in the phosphorus, which has been attracted towards the chlorine atom, and chlorine atom itself denotes one electron and results in a formation of PCl5. Especially the 3 electrons which is there in the p orbitals, they overlap with the chlorine atom and forms a sigma sp bond. Okay, so with a bond angle around 90 degree. This shows that in case of PCl5, which undergo the involvement of the d orbital, hence it is known as Sp3d hybridization. Okay. Now let us see the last hybridization, that is Sp3d2 hybridization. So here also you can see that there is an involvement of d orbitals. Is it right? How does the d orbitals will be involved during the writing of hybridization? Let us see now. Okay. So the intermixing of 1 s orbitals with the 3 p orbitals with the 2 d orbitals almost with the same energy and giving rise to the identical and degenerated hybrid orbitals, they are known as Sp3d2 hybridization. You can see that there is the involvement of 1 s orbitals and involvement of 3 p orbitals and the involvement of the 2 d orbital, and results in a formation of Sp3d2 hybridization. And these 6 Sp3d2 hybrid orbitals are arranged in octahedral geometry. So which geometry it has? It has octahedral geometry with a bond angle of 90 degrees with each other, and this arrangement can be visualized as 4 orbital arranged in square planar. You can see that all 4 orbitals will be arranged in the form of square planar, and other 2 will be present just above and just below the plane. Okay, when all the 6 hybrid orbitals are involved in a bond formation, and the shape of the molecules will be a regular octahedral shape will be obtained. So what is the shape here? Octahedral shape. So when we are dealing with Sp3d, we have learned that it always having trigonal bipyramidal, whereas in Sp3d2 it is regular octahedral structure will be there. Now let us see by taking the example of SF6. So by taking SF6, let us understand how does it forms the involvement of the d orbital to form Sp3d2 hybridization. So we know that in SF6, the central metal atom is a sulfur, and it has a electronic configuration of 1s square, 2s square, 2p6 and 3s2, 3p4. 3s2, 3p4. So how many electrons will be there? 16 electron will be there. So I will take note the last shell where it consists of 6 electron. Okay. So I have written the 3s and 3p. You know that the 3s which consists of 1 pair of electron. Similarly the 2p which consists of 1 pair of electron with another 2 unpaired electron. During the excitation, what will happen? 1 electron from the 3s and 1 electron from the 3p get excited to the d orbital and results in a formation of 6 unpaired electron. Is it right? 6 unpaired electron. And this 6 unpaired electron which has been reacted with the fluorine and which results in a formation of SF6. So sulfur will donate 6 electron, and this 6 electrons will be accepted by the fluorine and forms a SF6 hybridization, and we know that this hybridization which is nothing but a Sp3d2 hybridization. How come? You can see that this is a s orbital and this is a 3p orbital, and you can see that this is a d2. Is it right? So hence it is named as Sp3d2 hybridization, where you can see that during the excited state, 1 electron from the 3s and 1 electron from the 3p got excited and moved towards the d orbital. As a result of this, the d orbitals which also involved during this hybridization and results in a formation of Sp3d2 hybrid orbitals. Okay. Now let us see with the geometry now. This is the structure of Sp3 hybrid orbital. You can see that the sulfur, which is a central metal atom, which donates 6 electron, and this 6 electron will be accepted by the fluorine to form a sigma bond. Is it right? So these are the bond which you can see that. And you can see that the 4 hybrid orbitals which is present in square planar structure, but one orbital which is present above, one orbital which is present below, has this overall geometry which is known as octahedral or regular octahedral structure. This is how we can easily understand the Sp3, Sp3d and Sp3d2 hybridization in the hybridization concept. So in the next class, again we are going to understand more about valence bond electron pair theory, and again it is very important for the examination point of view. Whatever the concept which I covered in this session, I am telling you it is very important for the examination point of view, especially for your competitive exams also it is very important. Have a look on with the valence bond theory as well as with the hybridization concept. In hybridization there are 6 concepts will be there, that is Sp as well as Sp2, Sp3d2 and Sp3d and Sp3d2 hybridization. So work out with all this hybridization, at least know with one example how to write the structure as well as the geometry. Try to understand it, and we'll meet you with the next session. Till that, take care, be safe. Thank you.